This is section 2.5, using linear models, and it's a combination of about 3 sections, 2.5 in our regular book, and then in the very back of your book it's sections 2.2 and 9.1. Okay. The objective of this section is to graph and interpret paired data sets using scatter plots. Now, many of you have seen this before. This is not going to be a lot of new stuff for you. We're just going to kind of hit the basics of it and be able to draw some scatter plots from some given data. Okay. A scatter plot's a graph that relates two sets of data by plotting the data as ordered pairs. You can use a scatter plot to determine the strength of a relationship or a correlation. The correlation is going to be an important word you're going to hear over the next couple days in terms of this information. The correlation is the strength of the relationship between data sets. The closer the data points follow along a line with positive slope, the stronger the linear relationship and the stronger the positive correlation, okay, between the two variables. Now, they give you a couple of examples here in your notes, some things to look at. This is how you describe the strength and direction of the graph. So this is something you'll probably want to write down. This is describing the strength and direction. Now, direction is very easy. The direction, you have two options. Direction, you have two options. It's either going to be going in a positive direction or a negative direction. Okay? So as you can see from these examples here, we've got two examples of negative and two examples of positive. Positive from left to right is going up in an upward direction. Okay? Negative from left to right is going in a downward direction. All right, so another way to say this in terms of positive, on a positive correlation, as the x values increase, the x values get bigger and bigger, the y values increase. Now, for negative, it's the same thing as saying as the x value increases, the y value is decreasing, it's going down. Okay. Now, in terms of strength, you really have two options. You've got strong and you have weak. Okay. Now, in terms of the two options, you've got strong and you have weak. Strong means that if you were to draw a line through the middle of your data points, somewhat like so, then the ordered pairs are very, very close to that line. Okay, that's in the case of a strong. If I were to draw a line through these data points here, you'll notice the data points are a little bit farther away. They're not nearly as tight together. Okay, so we have weak and strong in terms of strength. And then the last one is we have no correlation, which means there's no linear relationship at all to that data. Okay, there's no trend to it. The data is very spread out, and there is no linear pattern. Okay, so you've got strong positive, you've got weak positive, you've got strong negative, weak negative, and then you have no correlation at all. Okay, now let's take a look here at an example. It says the table shows the number of hours students spend online the day before a test and the scores on the test. Make a scatter plot. How would you describe the correlation? Okay, so here's our data table right here. Okay, we're going to take this data and we're going to graph it. Okay, so we're going to plot these ordered pairs down on the graph that they have provided. Okay, so it says plot the data ordered pairs on the coordinate plane and label the right, or at the right, and label the graph. So the first thing we're going to do here, and this is going to be something that's very important, is to make sure that you label your graph. So as you're looking at the chart, usually, most of the time, if you have an up and down chart like this, the top variable is x, the bottom variable is y. So in this case, this is going to be the number of hours online. Okay, the y value, the y-axis, is going to be the test scores. Okay, again, as you look at these, most of the time the x value is going to be either on top or it's going to be the one on the left. Okay, so now I'm going to go through and I'm going to plot my ordered pairs. as I look at the graph. So I've got the ordered pairs 0, 100. We've got 0, 94. We've got 198. $188, 1.5 and 92, 1.75 and 89. Oops, that was incorrect there. A little too far. And 1.75 and 89 right there. We've got 275, which is right there. We've got 270, which is right here. We've got 378, which is here. 472 here. 4.5, 57, 4.5 and 57. About right in there. And 5 and up 60. Okay, so now I've graphed all of our ordered pairs. Okay, now as we are looking at these ordered pairs, okay, it says the data pairs are tightly clustered around a line. Okay, we're going to place it, and if you were to draw a line down the middle again, if I were to draw a line down the middle of my data, about the middle point of everything here, you'll notice they're not that far from the line. So I'm going to go ahead and mark a check mark here. Now, as online time increases, so as the x values increase, the test scores are increasing. And as you look at your graph, that's not true. I'm going to place an X in this box because that's not true. As the x values are increasing, as the number of hours online are increasing, the test scores are actually going down. Okay. Underline the correct words to complete the sentence. I'm just going to circle which one. There is a weak or strong positive, weak positive, or strong negative correlation between the hours online and test scores. Now, as you look at your graph, is the graph going down or up? It's a simple question in this case. It's going down, so in this case, we really only have one option. This is a strong negative case. Okay, strong negative correlation, relationship to this. Okay. Okay, now this concludes the first part of section 2.5. Okay, what I would like you to do as part of your assignment today in class is to take a look at your last page of your notes and go ahead and make that graph and come up with a strength and direction, and then also finish up whatever other practice problems that you have in class. This concludes section 2.5, 2.2, and 9.1 of the stats unit.